In this video, we'll be going over an adiabatic process. This is a process where there is no heat added or removed from the system, so no heat change. The pressure, the volume, and the temperature all do change. In this example, we have a piston that is going through an adiabatic process and is being expanded. We want to find the work done on the piston. On the top right, we have a graph of the adiabatic process. On the y-axis, we have the pressure in the piston chamber, and on the x-axis, we have the volume in the piston chamber. I have listed two isotherms on this graph to indicate that there is a change in temperature. The adiabatic process is represented on this graph as an adiabat. This adiabat represents all changes in pressure, volume, and temperature in the adiabatic process. Below the graph, we have two pistons that represent where the piston is at in the adiabatic process, at two different points we'll be using for the example problem. Now let's do an example problem. We are given a pressure at point 1 of 200 kilopascals, volume at point 1 of 0.1 meters cubed, and volume at point 2 of 0.5 meters cubed. We want to find the pressure at point 2. We can use the formula pressure 1 times volume 1 to the power of gamma of the substance, in this case air, equals pressure 2 times volume 2 to the gamma of the substance. We will first need to find the gamma of our substance, which in this case is air. The gamma is simply the specific heat of a constant pressure process divided by the specific heat of a constant volume process. In this case, the gamma of air is 1.41. You can find the specific heats and gamma of a substance you are working with by completing a Google search. Now we want to get pressure 2 to one side of the equation. We can do this by doing basic algebra. We get that the pressure 1 times parentheses volume 1 over volume 2 parentheses to the power of gamma equals pressure 2. Plugging in all of our numbers, we get a pressure 2 of 20,677 pascals. Now let's find the work done by the adiabatic process. We will once again be finding the area under the adiabat. Using calculus, we find that the work or area is equal to P1 times V1 minus P2 times V2 divided by gamma minus 1. Plugging in all of our numbers and pressing the enter key on our calculator, we get 23,565 joules of work completed from the adiabatic process. I would like to note that due to no heat being added or removed, or in other words heat equals 0, total work removed is equal to the total change in internal energy of the system. That concludes this video. Hopefully I've earned a like, share, or subscription. If you enjoyed this video, you may enjoy one of these videos as well. Let me know how I'm doing in the comments down below. Thank you for watching.